This is SpaceTime, Series 26, Episode 133, for broadcast on the 6th of November 2023. Coming up on SpaceTime, could the remains of an ancient planet be lying deep within the Earth's interior? Spacecraft Lucy's first asteroid encounter discovers a new moonlet. And a new theory that Venus once had Earth-like plate tectonics billions of years ago. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Back in the 1980s, geophysicists discovered two continent-sized blobs of unusual material buried deep within the Earth's mantle. One was detected roughly beneath the African continent, while the other is below what is now the Pacific Ocean. Each blob, formerly known as a large low-velocity province, is about twice the size of the Moon, and each appears to be composed of different proportions of elements compared to the surrounding mantle. Scientists first discovered the large low-velocity provinces by measuring seismic waves as they travelled through the Earth. Seismic waves travel at different speeds through different materials. And in the 1980s, the first hints emerged of large-scale three-dimensional variations deep within the structure of the Earth. In the deepest mantle, the seismic wave pattern is dominated by the signatures of these two large structures near the Earth's core mantle boundary, which scientists believe possess unusually high levels of iron. The high iron content means these regions are denser than their surroundings, and that's what causes the seismic waves passing through them to slow down, which leads to the name large low-velocity provinces. Ever since their discovery, the origins of these strange blobs have been a mystery. Now, a new study reported in the journal Nature suggests that they could well be the remnants of the ancient planet Theia. Theia collided with the Earth 4.5 billion years ago, creating the Moon. Now, according to the giant impact theory, Theia was a Mars-sized body, about a third the size of the proto-Earth. The collision between Theia and proto-Earth turned both bodies into a vast magma ocean, which slowly differentiated and solidified to create the Earth as we know it today. Ejected debris from that collision was flung up into orbit around the Earth, eventually coalescing and accreting to form the Moon. The new study's lead author, Qian Yuan from the California Institute of Technology, Caltech, says simulations have confirmed that the physics of the collision between Theia and the Earth could well have led to the formation of both large low-velocity provinces and the Moon as well. Yuan says some of Theia's mantle could have become incorporated into the Earth's own mantle, where it ultimately clumped and crystallized together to form the two distinct blobs, detectable today at the Earth's core mantle boundary. Meanwhile, other debris from the collision mixed together to form the Moon. But there's still one nagging question. Why did Theia's material clump together in two distinct blobs inside the Earth's mantle, rather than mixing thoroughly together to form the rest of the planet? And remember, just as much of the Earth was flung up into space to form the Moon. Well, the author's simulations are showing that much of the energy derived from the Theia impact remained in the upper half of the mantle, leaving Earth's lower mantle cooler than that estimated by earlier low-resolution impact models. Because the lower mantle wasn't totally melted by the impact, the blobs of iron-rich material from Theia stayed largely intact as they sifted down to the base of the mantle. Yuan says you should think of it like coloured masses of paraffin wax in a turned-off lava lamp. But had the lower mantle been hotter, Yuan says it would have received more energy from the impact, and it would therefore have mixed more thoroughly with the iron-rich material, sort of like different colours in a stirred pot of paint. The next step of the study is to examine how the early presence of Theia's heterogeneous material deep within the Earth's mantle might have influenced the Earth's interior processes, including plate tectonics. A logical consequence of the idea that the large low-velocity provinces are remnants of Theia is that they must be very ancient, at least 4.5 billion years. It therefore makes sense to investigate what next consequences they had for Earth's earliest evolution, such as the onset of subduction before conditions were suitable for modern-style plate tectonics, the formation of the first continents, and the origin of the very oldest surviving terrestrial minerals. This is SpaceTime. Still to come. Lucy's first asteroid encounter discovers a new moonlet, and a new hypothesis suggests that Venus once had Earth-like plate tectonics billions of years ago. All that and more still to come on SpaceTime. NASA's Lucy spacecraft has just completed its first asteroid encounter, flying by the small main-belt asteroid 152830 Dinkinesh and discovering that it's actually a binary system. The probe passed the potato-shaped space rocks at a distance of 425 kilometres, travelling at a relative speed of 4.5 metres per second. Back in late September, Lucy's optical navigation team undertook a slight course correction manoeuvre in order to target the spacecraft on the right trajectory for its close encounter with the asteroid. Then last week, mission managers sent the spacecraft what's known as the Final Knowledge Update, a package of data with the most up-to-date information about the relative positions of the spacecraft and the asteroid. That dataset was precise enough to guide Lucy over the following 800,000 kilometres towards the tiny asteroid. About an hour before the spacecraft's closest approach, when it was approximately 16,000 kilometres from Dinkinesh, Lucy began actively monitoring the position of the asteroid using its terminal tracking system. The system autonomously reorients the spacecraft so as to keep Dinkinesh within the field of view of its science instruments as the spacecraft speeds past. Now, this manoeuvre moves the high-gain antenna away from Earth, preventing the spacecraft from communicating with mission managers until it's completed the encounter sequence, and then reoriented itself so that its high-gain antenna was once again pointing back towards the Earth. And it accomplished that task successfully, marking the first use of the terminal tracking system and a successful operation to test the system in real spaceflight conditions. Dinkinesh was meant to be the first of 10, now 11 asteroids the spacecraft's visiting during its primary 12-year, 6.5 billion kilometre voyage of discovery. First identified in 1999, the asteroid rotates with a period of 52.67 hours. It circles the Sun on an elliptical orbit with an average distance of 2.19 astronomical units. That's equivalent to 328 million kilometres, and an orbital period of 3.24 Earth years. By the way, that name Dinkinesh, well, it's the Ethiopian name for the Lucy fossil, after which NASA's Lucy mission is named. In the Amharic language, the name means "you are wonderful." The asteroid was still unnamed when it was selected for exploration by Lucy's mission managers, and it was they who proposed the name Dinkinesh to the International Astronomical Union, which approved it in February this year. Of course, the Lucy spacecraft is named after the famous 3.2 million-year-old Australopithecus hominid fossil Lucy, discovered in Ethiopia in 1974. Because, like Lucy, Jupiter's Trojan asteroids, which are the target of the mission, are fossils of the solar system's early history. The mission's principal investigator, Hal Leveson from the Southwest Research Institute in San Antonio, Texas, says Dinkinesh really did live up to its name. This really is marvellous. In the weeks prior to the spacecraft's encounter with Dinkinesh, the Lucy team had already been wondering whether Dinkinesh might be a binary system, given how Lucy's instruments were seeing the asteroid's brightness change with time. And the first images of the close encounter removed all doubt. Dinkinesh was indeed a close binary system. From a preliminary analysis of the first available images, the science team estimates that the larger body is approximately 790 metres wide, while the smaller, the moonlet, if you will, is 220 metres across. Of course, the real prize of this mission will be arrival at the Trojans. Leveson says the Trojans are leftovers from the early days of the solar system, effectively fossils of the planet formation process, and therefore they hold valuable clues which will help decipher the solar system's early history. He says Lucy, like the human ancestor fossil for which it's named, will revolutionise science's understanding of our origins. Named after characters in Greek mythology, the Jovian Trojan asteroids circle the Sun in two swarms. One cloud leading 60 degrees ahead of Jupiter in its orbital path around the Sun in a gravitational well known as Lagrangian L4 position, while the other cloud trails 60 degrees behind the gas giant in another gravitational well known as the Lagrangian L5 position. Lucy will be the first spacecraft to visit these vast asteroid fields. By studying them close up, scientists hope to hone their theories on how the solar system's planets were formed 4.6 billion years ago, and also how they've ended up in their current configuration. In order to reach its targets, the 1,500-kilogram Lucy spacecraft is using a series of slingshot gravity-assist maneuvers of the Earth, one of which took place last year, and a second which is slated for next year. These will give it enough energy in order to reach its destination. Then in 2025, Lucy will fly past the inner main belt asteroid 52246 Donald Johanson, which is named after the discoverer of the Lucy hominid. And finally in 2027, it'll arrive at the Lagrangian L4 Trojan asteroid cloud, which orbits ahead of Jupiter. There the spacecraft will fly by 4 Trojan asteroids: 3548 Euripides and its tiny moon, 15094 Polymele, 11351 Lucius, and 21900 Orus. After these flybys are complete, Lucy will again swoop past the Earth in 2031, whereupon it will receive a third gravity-assist slingshot, flinging it out to Jupiter's Lagrangian L5 asteroid cloud, which trails behind the gas giant. There it will visit the binary Trojan asteroid 617 Patroclus and its satellite Menoetius in 2033. The 12-year mission may end with the Patroclus-Menoetius flyby, but at that point Lucy will be in a stable 6-year orbit between the L5 and L4 clouds, and mission managers may well decide an extension will be possible. Lucy's science package includes a panchromatic and colour visible imager and infrared spectrometer mapper in order to measure silicates, ices and organics on the asteroid surfaces. There's also a high-resolution visible imager to provide the most detailed images of the surface of the Trojans, a thermal infrared spectrometer to study their thermal characteristics and provide data on the composition and structure of surface material, and a radio science investigation to determine the mass of the Trojans by using the spacecraft's radio telecommunications hardware and high-gain antenna to measure Doppler shifts. Now, we can't leave this story without giving you some more details on what Lagrangian points are all about. Well, they're named in honour of the Italian-French mathematician Giuseppe-Louis Lagrange, who had been working on the general three-body problem of orbital mechanics, one which I can assure you still poses head-scratching for first-year physicists today. And yes, I do speak from personal experience. The Lagrangian points are positions in space where the gravitational pull of two bodies, such as the Sun and the Earth or the Earth and the Moon, tends to cancel each other out while equalising the centripetal forces needed for a small object to move relative to the two larger bodies, and so allowing the smaller object to remain there for extended periods of time. Basically, it's a gravitational well. Once you're in there, you don't need to use much energy in order to stay there. There are 5 Lagrangian points, known as the L1, L2, L3, L4 and L5 positions. L1, 2 and 3 are along a line connecting two bodies, say the Earth and the Sun. L1 is between the Earth and the Sun. It's often used by spacecraft needing uninterrupted views of the Sun, such as the Solar and Heliospheric Observatory satellite SOHO. The L2 position is on the opposite side of the Earth to the Sun. In other words, it's in perpetual darkness. It's home to the Planck spacecraft and the James Webb spacecraft because it's ideal for astronomy, because it's close enough to communicate with the Earth and it's still in the Earth's shadow, keeping the Sun, Earth and Moon behind it. The L3 position is on the opposite side of the Sun to the Earth. Because the L3 position's always hidden from the Earth by the Sun, it's become popular in science fiction as the location for hypothetical second Earth planets. L4 and L5 provide stable orbits around 60 degrees ahead and behind Earth as it orbits the Sun, and these are where Trojan asteroids, such as those around Jupiter, are commonly found. This report from NASA TV.
We are going to an amazing variety of objects with this mission. And it's really almost pure luck that allowed us to get as many rich targets as we are. Literally, the planets were aligning to allow us to do this mission.
The Lucy mission is named after the Lucy fossil, the Australopithecus fossil that was discovered in the 1970s in Ethiopia. And just like the Lucy fossil transformed our understanding of hominid evolution, the Lucy mission will transform our understanding of solar system evolution.
Trojan asteroids are an interesting population of small bodies that are left over from the formation of the planets, and they lead or follow Jupiter in its orbit by roughly 60 degrees. If you just look at the gravitational attraction of the Sun and Jupiter and put something exactly 60 degrees in front of Jupiter, it's stable forever. So as a result, these objects are really the leftovers of planet formation. The stuff that went into growing Jupiter and Saturn are now trapped in these locations. We're visiting both of the Trojan swarms. In the first orbit, we're going into the leading swarm, and we're going to encounter 4 Trojan targets.
Eurybates, Ptolemy, Lucas, and Orus. And from this, we're going to sample the diversity in sizes, and colors, and compositions. The first 2 flybys happen just about 30 days apart, so it's going to be a pretty busy kickoff to the season of exploring the asteroids in the L4 swarm. And then we'll fly past Earth again and out to the L5 swarm.
The final object we're visiting, which I must admit is my favorite, is a binary object.
So that's 2 Trojans that orbit a common center of mass. It's called Patroclus and Menecius.
These objects are nearly identical in size that orbit one another.
From the Lucy mission, we're going to study the diversity of our targets because that tells us something about their origin and where they came from.
The interesting thing about small bodies in general is they are the leftovers of planet formation. If you look at the 8 planets that we know about, for example, they are highly processed because of internal processing. These asteroids are objects that really haven't changed much from when the planets assembled themselves. And as a result, by studying them, we can figure out the physical conditions of the early solar system, as well as how the planets grew and how they moved around early on.
All of that will help us form a detailed picture of what these objects really look like. Because right now, our best images are just a point of light. Even using the Hubble Space Telescope or adaptive optics on large ground-based telescopes, we can't see surface details. And it's going to take the Lucy mission to go to these targets and see what they're really made of and what they look like.
And in that report from NASA TV, we heard from Lucy mission principal investigator Hal Leveson from the Southwest Research Institute in San Antonio, Texas, and Lucy mission deputy principal investigator Kath Alkin, also from the Southwest Research Institute. This is SpaceTime. Still to come. A new hypothesis suggests that Venus once had Earth-like plate tectonics billions of years ago, and later in the science report, a new study has found a link between cell phone usage and semen quality. All that and more still to come on SpaceTime. A new hypothesis suggests that Venus may once have had plate tectonic movements similar to those believed to have occurred on the early Earth. The findings, reported in the journal Nature Astronomy, sets up tantalizing scenarios regarding the possibility of early life on Venus, as well as its evolutionary past and the history of the solar system. The study's authors combined atmospheric data from Venus with computer modelling to show that the composition of the planet's current atmosphere and surface pressure could only be possible as a result of the early formation of some type of plate tectonics, a process that involves multiple continental plates pushing and pulling and sliding past or beneath one another. On Earth, this process intensified over billions of years, forming new continents and mountains and leading to chemical reactions that stabilized the planet's surface temperature, resulting in an environment that was more conducive to the development of life. Venus, on the other hand, may well be Earth's nearest neighbour and sister planet, but it's gone in the opposite direction, and it today has surface temperatures hot enough to melt lead and surface pressures 100 times greater than that found at sea level on Earth. And that's all a bit confusing. After all, both Venus and Earth were made at the same time, they're the same size, they were made out of the same material and under the same conditions, but for some reason they've turned out totally different. Now, Venus does rotate backwards compared to the other planets in the solar system, and that may have something to do with it all. But that's for another story. The explanation for the difference being posed by this paper suggests that the planet's gone the way it has because it has what's known as a stagnant lid, meaning the planet's surface is just one single plate, with minimal amounts of give, movement and gases being released into the atmosphere. And the new study suggests this wasn't always the case. To reach their conclusions, the authors used the current data on Venus's atmosphere as the endpoint for their model. And they started by assuming that Venus had a stagnant lid throughout its entire history. Now, using this as the base, their simulations found recreating the planet's current atmosphere didn't match up with where the planet is now in terms of the amount of nitrogen and carbon dioxide present in the current atmosphere and its resulting surface pressure. The researchers then simulated what would have had to have happened for the planet to get to where it is today. And eventually, after a lot of trial and error, they were able to match the numbers almost exactly when they accounted for limited tectonic movement early in Venus's history, followed by the stagnant lid model that exists today. Their paper suggests that the early tectonic movement on Venus, like on Earth at the time, would have been limited in terms of the number of plates moving and how much they shifted. And of course, it would have been happening on both Earth and Venus simultaneously. And that's led the study's lead author, Matt Weller from Brown University, to say one of the big picture takeaways from the study was that there were likely to have been two planets at the same time in the same solar system operating in a plate tectonic regime, the same mode of tectonics that allowed life to exist on Earth today. He says this bolsters the possibility of ancient microbial life on early Venus, which shows that at one point the two planets were more alike than previously thought. The work also suggests that the planets may transition in and out of different tectonic states, and that this may actually be fairly common. In fact, Earth may be the outlier. But of course, this also means that we may have planets which transition in and out of habitability rather than just being continuously habitable. As far as we know, Earth is the only place in the solar system which currently experiences plate tectonics, and consequently the only planet known to have life. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a Science Report. A new study has found a link between cell phone usage and semen quality. The findings, reported in the journal Fertility and Sterility, are based on UK research of 2,500 men over a 13-year period. The study looked at the possible association of radio frequency, electromagnetic fields, and semen parameters. The authors found decreasing sperm numbers with increasing mobile phone usage. Professor Alison Campbell, Chief Scientific Officer with Care Fertility, says there's no confirmed explanation for the findings. Campbell says sperm morphology and motility were not seen to decline with increased use of cell phones as the sperm numbers did. She says while sperm numbers matter, the ability of sperm to swim, have healthy intact DNA, and be the right shape is at least just as important. Meanwhile, andrology professor Alan Pacey from the University of Manchester says one of the study's main criticisms was that the cell phones were self-reported. Nor could the study determine whether cell phones were just a surrogate marker for another aspect of men's lifestyle or occupation that was the real cause of changes in their sperm quality. For example, men usually keep their cell phones in their pants pocket, thereby causing an increase in temperature in the testicular area. However, Pacey says he was still intrigued by the findings, with the biggest effect being apparently seen with older 2G and 3G phones compared to more modern 4G and 5G versions. A new study warns that the impacts of marine heat waves on marine life may be worse deeper down in the ocean. The findings, reported in the journal Nature, are based on a study looking at the duration and intensity of heat waves, which have been found to persist longer in deeper waters. The authors say marine temperatures are often measured at the sea surface, but reanalyzing data and observations of marine heat waves from between 1993 and 2019 at depths of up to 2,000 metres found these heat waves can lead to repercussions for up to 2 years after the surface event had ended. Scientists now say that the 2022 Hunga Tonga Hunga Hape volcanic eruption shot an unprecedented amount of water vapour into the sky, reaching heights of up to 55 kilometres and depleting 5% of the ozone layer in some regions in just a week. A report in the journal Science details balloon measurements taken all the way over at the Reunion Islands in the Indian Ocean, half a world away from Tonga in the South Pacific. The readings are helping scientists understand how volcanic eruptions influence climate and ozone chemistry. The authors say the increased humidity in the stratosphere from the eruption led to a series of interactions between other materials shot out by the volcano, and that ultimately broke down the ozone both over the tropical southwestern Pacific and Indian Ocean regions. Well, there's been another Bigfoot sighting in the United States. The latest, by a dude from Vermont, is drone footage. But as Tim Mendham from Australian Skeptics points out, the vision of the suspicious Sasquatch has a few problems.
This Ken put up a drone with a camera. He said he was trying to film a mama bear and its cubs, and instead he found this weird figure walking through the trees from on high. And he said, "Oh my God, what in the world? What is that? That's incredible," he was saying, speaking over while he was filming. There were two issues with this. One, it looked very much like a man in a gorilla suit. And two, he didn't follow it all the way when he's guiding his drone. He let it walk out of frame and totally disappear. And you think, hang on, you should be following this for hours, however long your drone's going to last. But no, he sort of only had a very brief filming of it. It wasn't like it was hidden by the trees. He was looking straight down. He could still see it. The second thing is this fellow talks to himself a lot, obviously. When he's filming, he keeps saying these things out loud. And you think they don't really sound like someone who's totally flummoxed and stunned by what he's seeing. It's someone who's sort of making statements, "No way, are you serious?" He says, he's quoted on this thing, and, "That's incredible." And it just doesn't ring true, unfortunately.
Well, there are a couple of other problems with it as well. One is the fact that it's daylight, clearly daylight when this was taken. And if you've ever watched Finding Bigfoot, you know they only come out at night. That's why you get all the night goggles and things like that.
Yeah.
And also, they don't walk like this. He was walking like a Homo sapien, not like a 10-foot tall creature that's twice as wide as a human. And that's the other thing. He wasn't wide enough either.
Wasn't white enough?
Wide, fat, muscular. And the suit was flopping on him as well, you'll notice.
Now, there's actually a lot of examples of people who are mistaking certain animals for Bigfoot or weird things you see in America.
Well, we've had a study recently where they've found a correlation between Bigfoot sightings and sightings of black bears. As the black bear population increases, Bigfoot sightings increase.
Yeah, there's also cases of people mistaking deer who can stand up on their back legs and seeing them as
antlers are a giveaway, but
not necessarily with antlers, but 10-foot tall creatures with long skinny arms, etc. And they've actually shown that these things are a deer standing up on their hind legs, and they can do it for a while. And because most films of these things are fleeting.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.